Hello, my name is Professor Johnson, and today we will be discussing the geometric distribution. So with our geometric, it relates to a binomial in the idea that we have success and failure. But with our success or failure, with geometric, you can imagine that you fail many times. Maybe you don't fail at all, but you fail, and then you get your first. You're looking for the first success, okay? So you're going up to the first success, okay? So it's very different than binomial in that with the binomial, you'll need a number of trials. But with geometric, you don't care about the number of trials. You're just caring for the first success that shows up. Now with geometric, you have x is distributed geometrically. All you care about is the probability of a success. So that little p, that p is the probability of success. And if this is all that we know, the probability of success, the mu, the mean, the expected value would be 1 over the probability of success. So mu, the mean, is 1 over p. Okay, so let's go into an example. Imagine rolling a 6-sided die and hoping to get a 1. Okay, if you were to roll a 1, let's just think of the probability of rolling a 1. If you're getting a 1, you have 6-sided die, that's just 1 out of 6. So the probability of success is 1/6. Now, our geometric question comes into play here. How many rolls are expected before the first roll of a 1? Now, expected, that is expected value or the mean. And the mean is 1 over 6, okay? Now, you have to be careful if you type this in your calculator, okay? So you put parentheses around the denominator. But really, I know a fraction over a fraction really flips up. It would really flip up to 6 rolls. So truly, it's expected for 6 rolls to occur before you get your first 1. And that makes sense because if there's 6 sides, you'd probably have to roll it 6 times to get any of the 6 sides, which is kind of a mouthful. But continuing on, let's continue with thinking about rolling a 6-sided die, and we hope to get a 1. Okay, so we're hoping to get a 1. Now, what is the probability of getting your first 1? So we're thinking of failing, and then we get our first 1 on the 5th roll. Okay, so the 5th roll is your success. So imagine you failed, and then your success is on your 5th roll, right? So the probability of failure is really Q, and Q comes from 1 minus P. And that would be 1 minus 1/6. So you know, rolling anything other than the 1 would be a chance of 5/6. So 5 out of 6 would be all of these. And then the probability of getting a success is 1/6. Now what you really do with the geometric is you multiply this all the way through. And a nicer way to do this, you see how you have 5, 6, really that's 4 of them here. You failed 4 times, and then your first success occurred. So in your calculator, it'll be easier, a little bit less of a hassle doing that. Okay, so then you can see that this is approximately 0.80, okay? About 8% chance, okay, that the 5th roll will be your first one. Now, there is another way to do this using the calculator, and this can be found using geometpdf in your calculator. Now we're using PDF because it was exactly the 5th roll, okay? Exactly on the 5th roll. Now, where you find geometpdf in the calculator is second vars, and it's all the way at the bottom. So if you hit up, you'll get to the very bottom. Now there's PDF and CDF. PDF is for single. CDF, C stands for cumulative, so you're adding up events, but we're just interested in this one event. Now, the probability of success was 1 out of 6. Getting that rolling a 1 happens 1 out of 6 on the dice. And the X value, we want the 5th dice roll, so the X value would be 5 here. Now, when you type this, you can see it showed up as geometpdf. You put 1/6, comma, 5. Close the parentheses. When you hit enter, you see, just like magic, you get the same exact value. So truly, you could multiply them out like we did here at first, or you could just simply use geometpdf in your TI-84, or even the 83 calculator follows this as well. But with the 83 calculator, you will not have a menu. You just have to remember the order of probability of success, comma, and then the number you're interested in. Okay, so how about we do a CDF example? So from here, Joe Harris had a 3-point field goal shooting percentage of 47.4% for the NBA's 2018-2019 season. You can get this from ESPN.com or any other statistical online resource. For a randomly selected game, what is the probability Joe makes his first 3-point shot on or before his third shot attempt? So on or before. So you see how I'm interested in getting a success by the 3rd shot, or we would be happy with a success on the 2nd shot or the 1st shot even. Okay, so you could think of it as like you could fail, and then you could get a success, or you could fail, then you could get a success, or you could just get a success right away. We're thinking of all those possibilities. But in the calculator, we can use geometcdf, cumulative, because we're adding up different possible cases on or before the 3rd shot attempt. Okay, so we'd be happy if he made it on his 1st shot, or the 2nd shot, or the 3rd shot. So that's why we're using a CDF instead of the other example from before. Now, the probability of success, we could just assume that P is going to be 0.474. Now, you need to convert percentage to probability. Okay, now you could do that by taking 47.4 and dividing by 100, or you could imagine moving the decimal place 2 places to the left. Okay, now in our calculator, we'll put 0.474. If you forget to convert to decimal form, you'll get an error in your calculator. And then we want on or before the 3rd attempt. So we'll just tell it, so 2nd vars, and go to letter F, the very bottom, 0.474, X value is 3. When you hit enter, you'll get equals, and if we round to 3 decimal places, 854. Okay. Now, another way I could encourage you is to find the PDF for each of these 3 cases individually, and if you add them together, you'll get 0.854. Thank you for watching.